Hi, I'm Olivia, and I'm an Insight AI Fellow, and I worked with UCSF to create Resident, which is an emergency medicine resident schedule. So the problem is, in hospitals across the United States, emergency departments are open 24 hours a day, 24 hours a day, 7 days a week, and there are about 53,018 emergency medicine residents that need to be scheduled in all of these hospitals. Scheduling is really difficult because there's all of these constraints and they differ across hospitals. So right now, this is being done manually. So each hospital and each facility and each hospital spends about 18 hours each week creating a schedule. And it's something like a Sudoku puzzle because you have shifts and then you have residents and you have all of these constraints between those. You need to make all of these pieces fit together. So when I started to think about the problem, I started initially thinking about solving it using reinforcement learning. So I wanted to define state action reward cycles and virtually step through and understand if there's a positive or negative reward policy. And that turned out to not be an ideal solution simply because all of the constraints initially in the problem are well defined. Then I started thinking about, okay, I could use linear programming, but I didn't necessarily need an objective function. All I had was variables and constraints. So after talking with a few people in the Inside program, I realized that this is a very well-defined operational research problem, and there's something known as constraint programming, which falls in line with that, which I use to solve this problem. So because I'm using constraint programming, I have all of the constraints for an ideal schedule defined. So a schedule has 28 days and 30 shifts in a day for the UCSF emergency medicine resident scheduling system. And so there's basically 840 different cells in a schedule. And that turned out to create a lot of different possibilities within that domain. And when the emergency medical department gets in all of the information for all of the medical residents, it looks something like this. So you have residents who are floating through departments in the hospital, including the emergency department, but they're not only in the emergency department for the entire year. So the only cells that matter here are the blue and the pink cells because those indicate when a resident is going to be floating through the emergency department. So the way that I set up the problem is by breaking it down into shifts, which start at a particular hour and end at a particular hour. There are different facilities within this hospital, so there's 4 of them. And then there's a certain number of residents that, like a maximum resident number for every particular shift. And there's other constraints, like if a resident is working one particular shift on day 1, on day 2, they're not able to work any of those shifts. So because all of that is really well defined, I used the Google Operations Research tool to determine all of the feasible possibilities for schedules given these constraints. So what I produced are a few a lot of data frames that look something like this, where the rows indicate the facility, the shift number, and the resident number, and the columns are just the day and the month. And one schedule is a month. So this is a month's worth of data with in the cells, those are resident IDs. And I produced a front-end web application, which I launched, which is just a calendar, and that data from that data frame will go into this calendar. If I had more time, I would use a machine learning solution and think about optimizing the schedules for different types of residents, maybe residents who don't like to work in daytime, they only like to work at night, maybe parents, or other lifestyle choices. And some of the engineering challenges I had were thinking about how to flatten the data and actually get them into the front end. So about me, my name's Olivia. I'm very interested in like dance, and I have a data engineering and data analytics background, but I'm really interested in moving into research, specifically like reinforcement learning, and that is why I tried to start with a reinforcement learning solution to this problem.